Hi, today we're going to be going over the quadratic regression notes. So if you remember back to IM1, you went over linear and exponential regression. So today we're going to go over linear regression and quadratic regression. You are going to need this for next week for the second half of our selfie project. So here we have linear regression. So it's going to be y1 tilde. And if you look at your keyboard, it should be right under the escape key. And then we're going to go mx1 plus b. And you can see that is our equation. You can also do it as ax1 plus b. Doesn't matter. So it could also be ax1 plus b. Now, quadratic regression equation, it's going to be the quadratic formula, but we still have to put the ones, and the ones just mean that when we get our information from a table, it's x1, y1. All right, so what we're going to do is we're going to plug this table into Desmos. So let's see. Sorry, I need to turn the computer around so I can get it to partial. There we go. Now we can do partial. So we're going to write it. And we're going to go to plus, we're going to go to table, and we're going to start putting all of those numbers in. So everything in the left-hand column is going to go in the first box. Right-hand column goes on the right box. So if we do 0, 2, and then y's. And if you notice right here, they do have the plus sign with the little magnifying glass. It's easier to push it so that way you can see all of your points. So now we're going to be putting in the linear regression equation and then the quadratic regression equation. So y1 tilde, that's what the little squiggly line means, ax1. And if you notice, I'm just pushing the 1. I'm not making it go down any farther. I'm not doing a subscript. I'm just writing it, and it automatically knows how to do it. And I'm putting A because I'm used to doing A. And here we get the A is 0.365323. We just need it to two numbers after the decimal. I will be fine with that. And then the same thing with the the B value. All you needed is two decimals at the end. So we can do it as 0.37 and 7.34. And if we write the equation, and unfortunately it does go away, we're going to write it y equals 0.37x, and our b was 7.34. Now the r value, and we're not looking at r squared, we're just looking at plain r. This is going to tell us how good of a fit the line is. The closer it is to 1 or -1, the better. This is sort of halfway. And so we're going to write it in again. So it's 0.6076. Now, we're going to do the same thing. We're going to do it with a quadratic. So I'm just going to go down. Going to go down to the next one. Let me get rid of that. Maybe that'll move it. So we're going to go y1 tilde ax1, and then you need to raise it. So I do shift 6 squared, or if they're typing it, just do square. And then I'm going to go plus bx1 plus c. And just by looking at it, I can see the quadratic definitely hits more of the points or is closer to more of the points than if we did the other. And here again, we have our A, which is going to be negative 0.1, and I'm going to round it to 2. B is 2.11, and C is 4.22. I'm going to round it because after the 1, it does have a 5, so I'm just going to round it up. And unfortunately, this one has an r squared, not an r, so we're just going to use that. And you can see that this r is much closer to 1. So this one is definitely a much stronger correlation, much nicer. So if we write it, y equals negative 0.12x squared plus 2.11x plus 4.22. So all I'm doing is plugging in the A, the B, and the C into the equation. That's it. And the R was 0.9584. And just like I was saying before, this one is going to be more accurate because the quadratic is more accurate because the R is going to be closer to 1. So and then using your equation, what is the approximate maximum height of the ball? So we can go back, look at Desmos, and we can always look at the maximum height. So here, maximum height would be our vertex. The x would be the time or the distance in feet. If we look back at our table, the height would be 13.675. So it would be 13.675 feet. All right, we're going to do the same thing again, and I want you to try it. You're going to plug it in and do the same thing. Now, I'm going to leave my formulas there, so it just makes it a little bit easier. You can always move the tables around, but this one, I do want it to be x1 and y1. Let me see if I can make this one a little bit smaller. There we go. Doesn't always like to work, but it does. When it does, it's great. Oops. It likes to move around on me. Okay. And remember, if you want to see them a little bit better, you can see them here. Here you have my numbers. Hopefully they match yours. And then what we're going to do is write the linear regression equation. So we're only taking we're going to take the A, put it in for the M, take the B, put it in for x squared. And there's your equation. And we're going to take the r. We're just going to do the regular r. And it's very rare that it's only 3 numbers. It is usually 4. More often than not, when you do look at it, it will be 4. Okay, same thing with the quadratic. Remember, we're putting in an a in front of x squared, b in front of x, and then c. And you could have done 76.30. I'm fine with either one. Here they are. Now, as to decide which one is more accurate, definitely is going to be the first one. It is more linear. So if we look at what it looks like, we can see it's going through more or getting closer to more of the points than if we have the quadratic. So if we do the quadratic, it's going to come up, it's going to go back down. It's not that one. And if we need to put it back in there, we can see the points. The R value is definitely closer to 1, so we are going to do it. This one is going to be linear. Because it's closer to 1. And the question is, predict the test score of a student if they study 5 hours. And the 5 hours is going to be your x value. So what we can do, we're just going to plug 5 in for x. And you can just solve it. And since you have Desmos up, that's the nice thing. Just plug it right in. And you can see we have the answer right away. So if they studied 5 hours, their score is probably going to be 103.56%. So not bad. Okay, so you guys are going to practice this. Make sure you put this in your notebooks, and then you're going to be doing an assignment that you can find on Google Classroom. I will see you guys on Monday, and good luck on this assignment.